And we are 4 members. I'm Kanika Malhotra. We have Shivani, we have Shaurya, and we have Swasti Srivastava. We'll be now starting a presentation. So moving on to our first slide. In our first slide, the question that we have gone with is what are some of the design consideration you would have for designing the storage feature, and what all would you need to consider for the security of the documents while designing the architecture. The slide name is documents storage, the design and security approach that we would like to take. So our first approach would be having a user-friendly feature design. So we'll in the mobile app, we'll enable users to upload, view and manage their documents like license and insurance, and we'll also sync it to the scooter's tablet dashboard. That will give them an easy access, and it will also allow the offline access for the users. Now to store the document, we'll go with cloud-based document storage. Documents will be securely stored in encrypted cloud storage with associated metadata. We'll use cloud storage like AWS, and there will also be option for uploading the data and which file type are they uploading. This will allow efficient access, and this will organize the documents better. And for security, we'll use blockchain based security. So this will allow to store the document hashes. This will ensure tamper-proof verification authenticity, and any unauthorized changes will be detected instantly. Now moving on to the next slide. For the next slide, the question that we did was use the inside and outside and technique of releasing a product to the market and list the top 5 things you would do in inside out planning to release the new app to the market, and outside and planning for releasing the new app. So for inside out techniques and uses, inside out approach means that we'll start and focus on the company's strengths like its knowledge, skills and resources. It focuses on what the company already has, and then to improve the product. The points that we'll use are internal expertise. The team that we have created, we'll use the team's deep knowledge of scooters hardware to ensure that the scooter works perfectly, and we'll integrate the app with to work seamlessly with the vehicle's feature. We'll test it initially before launch. We'll run internal tests on the beta version of the app, and we'll identify any issues and refine the app to make sure it meets the quality standards before it reaches the public. Also, the past feedback that we have gotten or the previous version of the app, we'll analyze the feedback, and if there was any negative feedback, we'll work on it, and on the positive feedback, we'll enhance those features and make sure those features work properly. Now moving on to outside and technique and uses. This approach uses on understanding what customers need, the current market trends, and what our competitors are doing. Firstly, we'll understand what our customers need. We'll conduct surveys and focus groups to learn what features customers expect in the app. We'll also use the feedback that we have gotten, and this the things that the customers need, like battery tracking, easier navigation, and so this will help us in work on those features, and we'll ensure that the features will work properly. And we'll also analyze what our competitors are doing and their strengths and weaknesses, like if they're doing something and that we should integrate in our app, we will. And we'll also go with the feedback that they have been receiving, and that is their weakness, and we'll try to improve it in our own app. So this will allow us to features that are lacking in their app, such as faster charging notifications, and we'll also ensure that there is more accurate vehicle diagnostics. Now moving on to the next slide. For the next slide, the question is what can be the business and operational metrics and measurements the company can use for the new version for the vehicle and the goals they have for it. Business metrics can be around revenue, profits, while operational metrics can be around quality, delivery time, etc. What all the metrics will the company measure their performance even when manufacturing and selling electric vehicle? So the slide is business and operational metrics for the new vehicle. So firstly, we'll say that if our customers are happy, which means we'll have a loyal customer base. So we'll use scores as customer satisfaction score and net promoter score to see how happy customers are with us and how are they likely to recommend us. Our goal would be to increase both the scores, both the customer satisfaction score and how much are they promoting us compared to our old version. We'll also go with our sales growth and profit goals. We'll measure how many scooters are we selling each month and how much profit we are making per unit. Our goal is to sell 50% more scooters in the first 6 months and move from a 10% loss per vehicle to a 10% profit per vehicle. We'll also track fast delivery and cost efficiency. We'll track how long it takes or how it long takes from order to deliver and how much it costs to produce each scooter. The aim is to reduce the delays and lower the manufacturing cost without losing or compromising on any quality. We'll go with how much better quality we have and how many fewer returns we are getting. We'll keep an eye on it to how many scooters come back due to issues. Our goal is to have zero key issues in the first 3 months of launch and reduce return rates with better quality control. We'll also monitor app crashes, loading speed, and user feedback. We'll work on the app experience and how it is. Our end goal is to make the app smooth, reliable, and easy to use, and it will solve any complaints from the previous version. Now, my teammate Shaurya Malhan will be explaining the next two slides.
Good evening. Possible reasons for performance issues. We may have unstable or low bandwidth connectivity between the scooter and the cloud, causing delays in real-time transformation. We might be dealing with unoptimized backend architecture where data is not efficiently ingested, processed, or stored in the cloud. The current data pipeline may lack proper queuing and buffering, leading to loss or delays during high data loads. We could be using outdated or inefficient APIs between the cloud and app, slowing down updates and syncing. The app may not be designed for real-time refresh, leading to stale or laggy information for users. Focus area for performance growth. We will implement edge processing on scooter. So basic filtering and compression happen before sending data to the cloud. We will upgrade to a more scalable and event-driven cloud architecture. Example, using message queues like Kafka or MQTT for real-time streaming. We will improve network handling using fallback mechanisms like store and forward to handle offline scenarios. We will design smarter APIs and data caching. So the app fetches only updated, relevant data instead of reloading everything. We will enable real-time sync logic in the app, making sure users always see live, actionable updates with minimal lag. Thank you. Now I will forward Swasti Srivastava to take on the PPT.
I will be discussing the question. The company would like the app to have intelligence and provide recommendations to the driver. What kind of data should the app to use ML or AI for this analysis? And if so, what can be the use cases? Next slide. Data collection from the vehicle. Battery performance data. We will collect data on charge level, charging speed, battery health, and how quickly the battery drains over time. Vehicle usage data. We will track speed, terrain type, motor temperature, vibration levels, and braking or acceleration patterns. Location and route data. We will use GPS to record the scooter's location, routes taken, traffic conditions, and elevation patterns. User behavior and habits. We will analyze when and how the user rides, charging habits, ride frequency, and typical travel times. Systematic diagnostics and maintenance logs. We will log error codes, sensor alerts, past maintenance events, and hardware usage for better service and planning. The next question that I'll be discussing is 10th, that is research on the evolution of the domain of electric vehicles and represent it on one slide in an impactful way on what has been the evolution and where you think it will be 10 years from now and what kind of feature functions will be available. How was the technology evaluated and what is the future directions for the technology? Use of AI/ML to make app intelligent. Battery performance data. We will collect data on charge level, charging speed, battery health, and how quickly the battery drains over time. Vehicle data, user behavior and habits, system diagnostics, and maintenance logs. Next slide. The evolution and future of electric vehicles. We are seeing battery tech leap from lithium lead acid and lithium ion and now to solid state, making EVs lighter, safer, and faster to charge. We have seen EV grow from lower range models to smart, long range vehicles with powerful batteries, rugged brakes, and OTA updates. We will enter a connected future with EVs using AI for self driving, predictive maintenance, voice control, and smart route suggestions. We'll see energy smart EVs that sync with homes and grids, enabling two-way charging and optimized energy use. In 10 years, we'll expect fully autonomous rides, 10 minutes charging, self-healing systems, voice first control, and AI powered driving coaches. Now, I will ask Sai Shivani to discuss on further questions.
So I'll be discussing the few more questions that we have in line. The first one that I am discussing is list the potential reasons for any two of the issues which the customers have complained about and write the test scenarios you would use to test and ensure that they have been fixed. Talking about the issue number one that we had was battery drops without warning. The potential root cause for this could be inaccurate battery management system calibration. Maybe the battery is something else, and on the app, on the display, we are getting some other value. Uh, Degrading battery cells over time affecting the performance. Poor software integration between hardware and the app for the charging status. Like I said, maybe the charging status is something else, and on the app or the dashboard that we are having, some other values has been displayed. The test scenarios that we will be having to take will be considering to check if it is fixed or not is low battery simulation test. Simulate the scooter running with less than 20% battery and verify timely warning alerts on the app and the dashboard. Battery drain monitoring. Run from full to zero battery test and log the charge drop rate. Check for the irregular jumps. Maybe if there are irregular jumps, then the battery calibration is not perfect between the app and the actual percentage of the battery. Real-time sync test. Disconnect and reconnect network. Check if the battery level updates correctly on the app or not. The second issue that the customers raised was app shows old or delayed information. Potential root causes for this could be backend API delay, caching issue, poor real-time update test. Perform on test. In different complete service offline to test app in offline mode and then reconnect, verify if the app syncs to the current scooter status or not. Like these are the test scenarios that we'll take into consideration to check if the issues that were raised by the customers are fixed or not. Moving forward to the next question that I'll be discussing is what can be a very user-friendly design of the tablet UI dashboard on the vehicle? What data should it show? Also, write the ways in which the user would use the touch screen to interact with the UI. Comment on the ways the UI would have by default and how the user can navigate on the UI and what all functions it should have. With the goal keeping in mind is easy to use. So this is a model of the dashboard UI that we are planning to have for the EZ, our EV scooter. Like in the dashboard, most common icons will be there in the bottom, with which the home dashboard, Google Maps, battery info, and the owner info, the documents that were asked in the upgradation settings, and also the settings icon will be there in the bottom. We can press and hold to pin the widgets in the quick access dashboard, and we can swipe up to switch between the dashboards. From home to Google Maps, we can swipe up and switch between the dashboards. We can have a swipe facility from left to right if we want to connect with the app and check the app list and pin it in the dashboard. We can swipe left if we want a quick access panel like brightness, connect to Bluetooth, etc. In the main panel, we can have time and weather, which are the mandatory ones. We can have Bluetooth connection status if the app is connected to the dashboard in the tablet dashboard in the scooter or not. We'll have the battery percentage, which will show real-time battery status of the scooter. Uh, the navigation summary. The Google Maps will have a navigation summary on the desktop itself, and the speedometer, which will tell the speed of the vehicle. The battery information tells us about the battery conditions and estimate the range, how much more the battery can sustain. And the owner info will have the information about the person who is owning the scooter, and the documents will be blockchain secured, and it will all be there in the dashboard. So this is our tablet dashboard UI that we suggest, that we propose. So I guess that is it for our presentation for the IPM course, and thank you.